mean for two shapes to be similar? You guys remember?
Congruent.
No.
Have a ratio. Similar.
Okay.
Something is the same.
Proportional. They're proportional.
The sides are proportional. I can't draw the same thing.
And the angles are congruent.
Oh, I think I can duplicate though. Oh, so close. Oh, that gets smaller. Gets bigger. Here we go. Duplicate. Enlarge. Okay, anyways. What do we know about the angles? They're identical. The exact same. So, like, all the matching angles are congruent. What do we know about the sides? They are not congruent,
They're proportional.
but their ratios are the same. Like, if this is side A and that's side B, then A over B should equal C over D. Should equal E over F. All the ratios of the sides have to be the same. Okay, so those two things. All the corresponding angles are congruent. All the corresponding ratios of sides are proportional. That means the ratios are equal.
Is that D over F?
E over F.
Oh.
How do you get a D out of that?
I don't know, I thought I heard you say D.
E over F. Okay. But it turns out with triangles that you can prove they're similar without proving all of these facts. Like, you don't need to say all three of those angles is congruent, all three. You don't need to say all those sides. You don't have to do all that at once. There's three ways. The first one is called side-side-side similarity. You guys remember side-side-side when we did congruent triangles? If all the sides are congruent, the triangles are congruent. For similarity, it's not all sides are congruent. Guess what it means?
They're perpendicular.
It means this. All their ratios are equal. Okay, side, side, side doesn't mean all three pairs of sides are congruent. It means the ratio of all three pairs of sides is equal. Okay, so if you just show that, you don't even have to worry about the angles. If you just show all three sides are proportional, then you're good to go. The other one is called, well, there's two others, but the next one is called angle-angle. Guess what that means?
Two angles are congruent.
Two pairs of angles are congruent. Okay, so if I know that angle is congruent and these two angles are congruent, then I know these triangles are similar by angle-angle. The reason you only need two pairs of angles is because
They add up to.
if two angles on a triangle are congruent, then the third angles have to be congruent because there's only 180 degrees. So anyway, if you get two angles that are congruent, all three angles are congruent, therefore the triangles are going to be similar. Okay, the last one is called side-angle-side similarity. Guess what that means?
Two sides are perpendicular. One angle is congruent.
Okay, keep saying perpendicular.
Oh, proportional. Ratio.
Yeah, whoops, I did it wrong. Yeah, so I'll give an example. Let's say this is like 8 and 4 and 6 and 3. So these two sides are proportional. 8 over 4 equals 6 over 3. You can even do 8 over 6 equals 4 over 3. But yeah, 8 over 4 equals 6 over 3. That's the side-side part. Two sides, two pairs of sides are proportional. The A part is the angle between those two sides is congruent. Okay, so it's like side-angle-side congruence theorem back in chapter, 4 or whatever. That was a long time ago. Where we had to prove two pairs of sides are congruent, the angle between them is congruent, but this time we have to prove two pairs of sides are proportional, not congruent. These are not congruent. All right.
Could you do it over 3 or
No, it's got to match. So you could do 8 goes with 4, like 6 goes with 3. Or you could do 8 goes with 6, like 4 goes with 3. Okay, or you could do backwards. You could do 4 over 8 equals 3 over 6. But 8 and 3 don't match. Like, yeah. Does that kind of make sense? Okay. Numero uno. As long as you follow a pattern, it will work. As long as you do it right. Okay, number 1, if the triangles can be proved similar, write a similarity statement, kind of like we did yesterday, and name the postulate or theorem that justifies. If not, explain why not. So, do we know the triangles on number 1 are similar?
Yes.
By what?
By
A. They put a little similarity symbol because just to differentiate it from the congruence theorems that we did back in the day. Okay, if it is similar, we have to write a similarity statement. So if I go
triangle ABC is congruent to
similar to,
E, F, D.
yeah, A would match E, B would match F, and yeah, E,
It
F.
was AA. Is that just?
Angle, angle are congruent. Two pairs of angles.
Wait, is that not the statement though?
No, this is the similarity statement because we're saying this triangle is similar to this triangle.
That's basically just us saying yes or no.
That is the postulate, huh? Oh, by the way, those 3 things, the postulate and 2 theorems, are listed at the right above the directions. So there you go. Number 3, are those similar? Well, you can't just assume, you got to kind of check. So if they are similar, the 8 on the big triangle should match the what on the little triangle?
This, 4.
Before. Because the little side, if they're going to be similar, the little side should go with the little side, the medium side should go with the medium, and the big should go with the big. So 8 would go with 4, like 12 should go with 6, and last one, a 16 should go with the 8 on the little triangle. So are all these equal? You got to check it. 2 ways to check it. Well, this one might be kind of obvious. You could divide all these, like 8 divided by 4, 12 divided by 6, 16 divided by 8. And if they all came out the same, yes, they're equal. Or you could cross multiply. Like if those 6 times 8, does that equal 4 times 12? Yes. Does 8 times 12 equal 6 times 16? Yes.
Simplify it.
You could reduce them all. Yeah, you could also reduce them all, yeah. So do they all reduce to 2 to 1?
Yes.
Okay, so they are similar by,
Is it S, S, S?
yeah, side, side, side. All the sides are in proportion. Are proportional. Okay, then we gotta say a statement. Triangle MNO is similar to, yeah, MNO is RQP, like reflected, right? We did that last chapter. So RQP. I don't know, this probably make a little more sense if you had been here yesterday. Hopefully. Because, like, we did this stuff yesterday.
Yeah.
But it's kind of like the congruent triangle thing. Okay, number 5. Do we have enough info to say that those are similar triangles?
Yes.
Number 5.
Angles.
Yeah, if angle CBD is 90, then angle ABD has to be 90. So they both have a 90, and they both have an angle A and angle.
Number 4 is are similar, right?
So yeah, by angle. What?
Isn't number 4 similar?
How can you tell?
Is it the angle
Yeah.
and the side?
Okay, but you got to make sure the sides are proportional, not just
You have to
Minus 2.
You have to do 6 over 4 and then 4 over
right.
2.
Does 6 over 4 equal 4 over 2? That's right.
On the side angle side, does it have to be in that order? This one side, then an angle, then a side, or can it be like side, side, and then an angle?
It's got to be side angle side.
How do you know if it's side angle side? I forgot how.
Okay, so the 2 sides, kind of like we did on the last one, you got to, but you only have to find 2 sides are in proportion. So my example at the beginning, where did I put it? Right here. Looks something like this. So like 8 over 4 equals 6 over 3. That's the sides part. And the angle has to be right between those 2 sides. And it has to be the same. So does it have an angle that's congruent? And then are the two sides around the angle proportional? Alright. Number 5, so we have triangle, I'll call it ABE maybe?
Abe,
Abe?
similar to DBC.
Yeah, A on the left triangle matches D on the right triangle. B on the left triangle matches B on the right triangle because they're both the 90-degree angles. And then that leaves C on the right triangle. Okay, number 7. So on 6, angle J is in both triangles. You guys see that?
Yeah.
On 6, angle J is in both triangles. So that would be the angle, and then the sides around them, like 6 is a side on the little triangle. That would
2 plus 6 is
right. The big triangle is 2 plus 6, so it's 8. So does 6 over 8 equal on the bottom 9 over 12? So that's how you check that one. I'll let you guys figure it out. There is one of those problems. They're not similar. One of the evens. Okay, number 7. State whether the given lengths could be side lengths of similar triangles. And if so, state the similarity ratio. Okay, this is kind of easy. We just got to check and see if these ratios are all the same. And if they are, then we're going to put yes, and then the ratio that they all reduce to. So, the 3 on the left triangle should go with what on the right triangle? Did they put all these in order for us?
I don't know, but 3 and 12 should go together.
Yeah, I think they did put it in order. So, because the small one should match the small one, the medium should match the medium, and the big should match the big. So does 3 over 12, question mark, equal 8 over 32 and 7 over 28?
We see if it even fits.
Okay, you could cross multiply all these or try to reduce all these. 3 over 12 reduces to
1 4.
1 4. So the answer is, whoopsie, yes. And what's the similarity ratio?
1
1 to 4.
Yes, 2, 3.
Did you actually not? Because I needed.
I don't prove it, I don't have it.
I think.
Is there a symbol for the ratio?
Oh my gosh.
I don't have it, bro.
Are you like, let's try to use like K or something like that?
Okay.
I didn't get this.
I don't even know what it is you're talking about.
They do actually use a K.
Waste.
Anyways.
Died.
So on number 9, it would be, does 2 over 3
Yes.
equal 3 over 4.5 equal 4 over 6?
It looks so desperate.
Yeah, it's a little bit hard to reduce it when there's a decimal. I don't think your calculator would reduce that one.
Mine does. You just have to click SU.
Okay. Yeah, if you divided both of those by 1.5, that would be 2 to 3. If you divided those by 2, that would be 2 to 3. So yeah, they are similar, and the ratio is 2 to 3.
What did I tell you? What did I tell you? Those reasons are so
Okay, number 11, name the postulate theorem that shows the triangles are similar. So they're telling us on this one the triangles are similar, so we don't even have to worry about them not being. Then find the value of the variable. So it's kind of combining today's with yesterday's, because after we show they're similar, then we got to find the missing variable. So if 11 is similar, we don't even have to check the ratios. By what theorem are they similar?
Side angle side.
Right. They have the 12 and then the angle and the 10, and on the right side they have the 6, the angle, and the 5. So those are similar by side, angle, side. And then we got to find y. Do you remember how we did that yesterday?
Y over 14 is equal to like 6 over
Right. We set up two equal ratios. Y goes with 14, just like what goes with what? 6 over 12 or 5 over 10. Or
I've already reciprocated.
5 over 10, you could reduce that to 1 to 2. That would make it a little easier. Or you could just do it. So then you cross multiply 10y equals 5 times 14, which is 70. Therefore, y is 7. So that's the answer, and this part's the answer. Two answers. Alright. Okay, how do we know that 13, those are two triangles are similar?
13. Angle,
Angle. They give us two angles in both that are congruent. This one might be a little tricky because their triangles share a side. Okay, let me write down angle. Okay, so we gotta be careful here. So Z in the big triangle matches what in the little triangle?
3.
3. Okay. So we went from big to triangle to little triangle. So on this next one, we need to go big triangle to little triangle. So what's another side in the big triangle that we know? 3. And that matches what in the little triangle? 2. So that 3 kind of gets used twice in two different ways. It's a little bit confusing. So basically we went big triangle to little triangle equals big triangle to little triangle. Cross multiply 2z equals 3 times 3. Yeah. 9 over 2. Or 4.5. The book, you didn't get that one?
No, I understand.
Yeah.
She said, I don't understand. No, I understand.
Well, I don't know how you went from like, I don't understand to doing.
Okay, we'll do it again. It is confusing because the big triangle and the little triangle both have this side, and that makes it confusing. So what I did first was I said Z is what we're looking for in the big triangle goes with what in the little triangle? No. Okay, see how this triangle is like lying down on its back? So which side is like the back on this triangle?
Pull them apart and then do
So
it.
be 3.
Yes. Okay, so we went, 3 is a side on the big triangle too though, so that makes it confusing. So then on the next one, since we went big triangle to little triangle, then you need to go big triangle to little triangle. But on the second part, the big triangle's short leg is 3, which matches the short leg on the little triangle of 2. So we used the 3 twice in two different ways. We used it as a side on the big triangle, and we used it as a side on the little triangle. Yeah, it is confusing. 15. This one might confuse us too, actually.
How?
Wait, before we start this,
Side.
Mr. Before we start this, how do you do number 10 if it's like already fractions?
Does 1/5 divided by 1/10 equal 4 9ths divided by 2 9ths equal 1/3 divided by 1/6?
What is 5 apostrophe mean? Oh, wait. That's
5 apostrophe. Okay, that's a B and a 4. Okay, yeah, kind of tricky on this one too. So, not side, no.
Oh, angle, side. Oh, wait, side, angle, side.
Right, we have side, angle, side, and then on the big triangle, side, angle, side. Oh, no, we don't have this side, sorry.
Yeah, no, those are-
We don't know the B, so we can't use that. What we do have this angle, but we also have
That one,
this one in both triangles.
so angle.
So it is angle, angle. Does look like side, side, side angle, side though. Alright. So let's go little triangle to big triangle.
So if you do
So B in the little triangle matches
3 or
4
4,
in the big triangle.
and then 3.
Okay, 3 in the little triangle
Not just 5,
matches,
2. 5
Okay.
plus 2.
right, the big triangle goes all the way from here to here, not just right there to there. So you have to do 3 plus 2 for the big triangle. That would be 5.
Then how come you wanna do B over 4 plus B?
Okay, so I'll separate them.
Because that would, it doesn't, like, that's not in the triangle.
Okay, B is the entire bottom side of the little triangle, just like 4 is the entire bottom side of the big triangle. The tricky part is 3 is the long leg on the little triangle, but 2 is not the long leg on the big triangle. It's 2 plus 3. So this is actually 5 long. So it's B over 4 equals 3 over 5. All right,
So
5B equals 12. 12 over 5. I think the book did put decimals, so it's either 12 over 5 or 2.4. Alright. 17. Find the height of the flagpole in front of a school if an 8-foot pole casts a 5-foot shadow. So 8-foot pole, how should I draw a 5-foot shadow?
What direction is the sun?
3.
We'll say the sun's like right here. Okay, the shadow is on the ground, right?
Mm-hmm. So it's
So-
gonna be like,
The sun shines down, you know, here's a 5-foot shadow.
8 over 5.
Okay, let me keep reading. At the same time, wait. 8-foot pole cast a 5-foot shadow. A flagpole, so a taller pole,
So it'd be 8 over X.
casts
and then
a 75-foot shadow.
5 over 75.
So this shadow is very large, 85 feet. So they want us to find out how tall is the flagpole.
So
So we can we know the shorter pole is 8 feet, casting a 5-foot shadow. So how do we know these two triangles are similar? Do you guys know?
Because they both have a side.
Right angle.
They both have a right angle,
And
And they
a
have-
side.
and the sun is gonna
hit them at the same way.
hit it at the same angle. So these two angles are the same.
So
So 75 instead of 80.
Oh, it's 75, okay.
so it'd be 8 over X and then 5 over 7.
Right. 8 over x equals 5 over 75. Basically, 75 is like 15 times bigger than 5, so this pole is going to be 15 times. But if we cross multiply, we get 5x equals 600? 560 plus 40.
What do you think, guys?
Hey,
Last 2 minutes, if you guys will do this for me, you know those Engage conference that we go to at Oakville, where we're gonna go and look at everything? They want us to individually register, so if you guys will come over here, take your phones, click on that, and then register for the Engage conference, that would be awesome.
at the college, is that what you
Yeah,
said?
that's the one where we take everyone to college. It's actually only sophomore, juniors, and seniors this year.
Great.
Yay!
What, what's the date on that?
I think it's April 17th, which is a Friday.
So like a month
In
away.
April, it's like a month away, but here's the deal, it's an inclement weather day for us.
No.
So if we don't have another bad weather day, we're actually gonna be out of classes that day. So,
They'll want to go anyway, I know that.
yeah, which is awesome. Y'all wanna go, we'll go anyway.
We only
Wait.
go skipping
Wait, so
school.
we have to
I'm
go?
not going
it's not an actual school day, okay, I can't force you to be there.
Well, actually, that's kind of bad news for you
That's
guys,
what I'm
because if it
talking
was
about.
a school day, then you get out of normal school.
That's
That's
right.
good.
Why can't we do it Thursday?
But it's not a school day.
It's
I know, so
there,
we're
let's
having
put
to
it
go out of
together.
our free own
Is
day.
it a weekend? Cause I have work.
No, it's like Friday.
I have work.
Okay, do we got one left, I think, or
Two.
does? Maybe I'll take off 21 because I don't want to worry about it. I'll do it anyway. Okay, no, I'm doing it. 19, a few friends want to place a log across a stream. I think they drew this one for us. For
It's a
some-
weird little log.
What did, 18 does not make any sense.
They drew a picture for 18 as well.
And you're just looking
But
for
what is
There's
it,
a person
but what's
with
it asking?
the-
It
The
says
person
find the
is-
depth of the rock.
Yeah, like the height of the canyon, basically. Okay, 19, a few friends want to place a log across the stream bridge to the treehouse. Given their measurements and to figure how long must the log be to reach across the stream? Those two little triangles that they drew out there on their little map are similar by angles, so the ratios should be the same. So on their little triangle, that would be kind of hard to do because you'd have to be like careful with measuring your angles when lining everything up. But on that little triangle, here let's do this. The log on the big triangle matches what on the little triangle? The log on the big triangle matches what on the little triangle? 7. So I'm going to say x over 7. X is the log. And then that leaves the 14 on the big triangle matches what?
4.
4. Okay, so that's how you set it up. So 4x equals
Oh, I was looking at the wrong picture. So,
7 times 14 is 98.
Which is
49 over 2.
Okay, yeah, I'll go ahead and put 24.5 for that one. That probably makes more sense in this context.
I think you're losing here.
Yeah, I think the
See
losing.
mine.
Look at that little split in the top. I'm going bald.
What did you say, Carolyn, finally?
I thought the picture for
Finally.
18 was switched.
I think
So-
so.
Really? What color is it? You want to dye your hair?
No.
Okay, 21, find the height of the tallest statue in feet and inches. Oh, that might make this hard. If a 5'6" tall person standing next to the statue. Okay, this is another shadow problem.
I hate shadows.
Okay, the 5'6" person casts a 7'4" shadow. The shadow is not the hard part, it's the feet and inches conversion. So,
Oh, 5.
Let's just turn it all to inches.
That's not too hard though, right?
okay,
The inches everything.
5'4"
Which is
casts a,
No, 5.
64 inches. Yeah.
5, 6.
oh, 5'6", 7'4". Sorry.
5, 6. Wait, don't you just have to put that over x and then 7, 4?
No, because we have to convert it to inches and feet, and like, because of like inches and everything.
Why?
Okay, and then what's the other thing? And the tallest statue casts a 12'8" shadow. So the shadow goes down here, and we want the height of the thing. So that's the X right there. Yeah, 5'6" is not like, it's not 5.6. It's not, I don't know, 56. It's 5 feet 6 inches means.
66 inches.
It means 5 feet is, 12 inches each, so it's 5 times 12 plus 6. Probably converting them to inches and then at the end turning them back into feet. That's probably the best way to go. So each of these 5 feet is worth 12 inches. 5 times 12 inches is 60 inches, plus the 6 inches that we already have is 66. Okay, and then for the 7'4", 7 foot times 12 inches is 84. Plus the 4 inches we already have is 88 inches. Okay. Over here, 12 feet times 12 inches each is 144
Plus 8
inches. Plus the 8 inches we already have is 152 inches. So that's kind of our ratio there. So,
66 over x
sure.
and then 88 over 153.
we probably could have reduced this ratio right here and just used that, but that's okay. It's a giant number if you don't reduce. 88x 66 times 152. So basically, whatever 66 times 152 is, we're dividing by 88.
114.
Okay,
Or that's 12 feet. Wait, no, it's not.
not quite. So we have to convert this back into feet and inches.
It'd be like 9 or 10.
So it takes 12 inches to make a foot, so we have to divide by 12. So 12 goes into,
Something, I don't know. 9.1.
well, we're not doing decimals.
I wrote it as one.
9 times 12 is 108, so the remainder is 6.
6 12, 1/2.
So it's 9 and 6/12, which means 9 foot 6 inches. Okay, they didn't do that on the evens to you guys, you don't have to worry about it, but that's our answer for 21.